Hi everyone, this is Mrs. GA, and today we're going to learn how to solve systems of linear equations with several variables. So today we're going to focus on three variable equations. Alright, so let's start by talking about the strategy we're going to use to solve a system of three variables. Our first goal is to look at your three equations and pick one variable that you're going to eliminate twice. Using two different pairs. So again, your goal is to pick one variable and eliminate it two different times. This should give you a system of two variables. So you should have two new equations that only have two variables, and they should be the same two variables. Then you can solve this system of two, which you already know how to do. You can use the method of your choice. Most likely it will be elimination, but maybe substitution. And then once you've solved for those two variables, you back substitute to find the last missing variable. So a few tips. Be strategic when you're picking the first variable to eliminate. So look through all of them and say which one would be the easiest to eliminate two different times. And also, I really recommend that you keep track of your equations, not only your original three, but the two new ones that you're going to create. I like to use a numbering system, which you guys will see. It really helps to show your work, or if you get lost along the way, you can kind of see what you did. But some people like to color code or something like that. But some way to keep your equations organized is highly recommended. Okay, so let's give this first example a try together. So remember, our first thing that we need to do is we need to look at all three variables and decide which one would be easiest to eliminate twice. So I see here, I think it would be easiest to eliminate our y's because I can add these two and they would eliminate, and I could add these two and they would eliminate. I don't need to change any of them. So my strategy is going to be to eliminate the y's first. So that's our first strategy. So again, I really recommend that you try this numbering system I'm about to use. Here's equation 1, 2, and 3. And then in each step that we do, we're going to write which equations we're adding so we can keep track of our work. So I see that we can eliminate our y's first by adding equation 1 and equation 2. So we can rewrite them here. Okay, and then if we add vertically, that gives us 2x plus 2z equals 14. And then I'm going to call this equation 4. I really recommend giving your new equation a new number. Again, we need to eliminate our y's again, so I can do that using a different pair. I can use equation 1 and 3, and that will give us that same result. So let's add equation 1 and equation 3. Again, here we're showing which equations we're using, making our steps really clear. Okay, and that leaves us with 4x minus 2z equals 4. And I'm going to call this equation 5. So you can see now we have a system of two variables, just x and z. So we can solve this with elimination. You'll notice that your z terms conveniently happen to be opposites already, so they're actually ready for the elimination method. So let's add equations 4 and 5. And that leaves us with 6x equals 18, so x equals 3. Okay, so now that we know x, we can back substitute it either into equation 4 or equation 5. So I'll substitute x into equation 5. So we have 4 times 3 minus 2z equals 4. And so this gives us negative 2z equals negative 8. So z equals 4. And now that we know two of our variables, we're going to pick one of your original three, and we're going to back substitute so any of the three will work. Let's back substitute both x and z, let's say into equation 1. So we have 3 minus 2y plus 3 times 4 equals 1. This gives us negative 2y equals negative 14. So y equals 7. So that means that we think that our solution is 3, 7, 4. We're going to write it as what's called an ordered triple instead of an ordered pair. So make sure you're writing in the correct order. It's always x, then y, then z. So as soon as you have your answer, we're actually going to be double checking all of our answer because it's really easy to double check, and it's important for these because it's really easy to make a small mistake along the way. So it's definitely worth doing. So we're going to plug in x, y, and z into all three equations to make sure they work. So we're going to substitute 3, 7, and 4. And you can see here that we end up with 1 equals 1, which is a true statement. So that first equation works. Now let's substitute into equation 2. So 3 plus 2 times 7 minus 4 equals 13. And that gives us 13 equals 13. So that one works. And last equation 3, 3 times 3 plus 2 times 7 minus 5 times 4 equals 3. And this does give us 3 equals 3. So that one works as well. So now that we've checked all three equations, we can finally box our answer, which is 3, 7, 4. And again, I really think it's important to kind of organize your work, at least in some way. So if you were, doing a test or quiz, it's really clear what you are doing in each step and where you're getting your equations and your different numbers from. It also really helps in case you make a mistake along the way, you may be able to trace it back a little bit easier. Okay, so at this point, go ahead and pause the video and see if you can give this one a try. And we'll check your answers in just a few seconds. Okay, so for this set of problems, the method that I chose to do was to eliminate the y's first. So maybe you eliminated your x's first, which is fine. You should still end up with the same answer, but of course your work is going to look a little bit different. But you can see here that I started by adding equations 1 and 2 to eliminate my y's. And then look here how I denoted my next one. I did 2 times equation 1, and then I added it to equation 3. So this is a really nice way to show not only what equation you're using, but how you changed it for the elimination method. And then you can see that I have 2 new equations, which I called 4 and 5, and now I have a system of 2 variables. So I solved that system by doing equation 4 plus 2 times equation 5 because I wanted to eliminate my z terms. And then that gave me x equals 4, which you can back substitute to find z equals 3. And then you can back substitute both of those into any of your 3 original equations to get y equals 6. And notice over here I have my full double check, verifying that my answer is 4, 6, 3. Okay, let's try another one together. So I'm going to start by looking at the 3 equations to form a strategy. So for this one, I think the easiest thing to do would be to eliminate the y's first. Of course, if you want to do a different strategy, you can, but that's the strategy that I'm going to use. So again, I will start by numbering my equations. And then I can see that I can eliminate my y's by adding 1 and 2. I just need to multiply one of them by -1. So I'll do negative equation 1 with equation 2. So that gives us negative x minus 2y plus 2z equals -1. and then 2x plus 2y minus z equals 6. And that leaves us with x plus z equals 5. And let's label this equation 4. Okay, so now we need to eliminate our y's again. So we can either do a 1 and 3 with a multiplication or 2 and 3. It doesn't matter either way. So let's do -2 times equation 1 added with equation 3. And then again, that should eliminate our y's a second time. So -2x minus 4y plus 4z equals -2. And I think by writing it like this, it also helps you avoid mistakes, so you know exactly what you should be doing to this full equation. And then equation 3 is going to stay the same. And then this leaves us with x plus z equals 3. So again, I'm going to call this equation 5. And you might already be noticing something a little weird, but that's okay. We'll keep going to see what's happening. So here we can try to eliminate either x or y. We just need to make one opposite. So let's do the opposite of equation 4 plus equation 5. But notice what happens when we do that. We get -x minus z equals -5. And then we get x plus z equals 3. So when we do this, actually, both variables eliminate, which doesn't necessarily mean no solution. Depends what's happening on the other side. So here we get the statement 0 equals -2. So since we end up with a statement that is just not true, we actually know that this is a no solution problem. And then that's all you need to do for this one. So again, if you eliminate completely and you end up with a statement that is not true, it's no solution. All right, so let's try one more together. So here, again, let's form our strategy and decide which one we want to eliminate twice. We could eliminate our y's twice. That wouldn't be so bad. We could also eliminate our x's twice, and then we actually only need to multiply by 2 instead of 4. So really, it's up to you. I'm going to, let's say we'll eliminate our y's. Again, it really doesn't matter as long as you are sticking to your strategy. So if we want to eliminate our y's, we can start by adding equations 1 and 2. And we don't need to change them, which is nice. And then 2x plus y plus 4z equals 2. Okay, so that leaves us with 3x plus 9z equals 0. And it's totally fine to end up with 0 on the right side of your equation. And again, we're going to call this equation 4. It's our new equation with only 2 variables. Okay, so now we need to eliminate our y's again. We can do that by multiplying our first equation by 4, which will give us -4 here, and then adding it to equation 3. So we can do 4x minus 4y plus 20z equals -8, and then 2x plus 4y minus 2z equals 8. This leaves us with 6x plus 18z also equals 0. And we'll call this equation 5. Okay, so now we have a system of 2. So let's see if we can eliminate maybe our x's. So we can see that I would need to multiply this equation 4 by -2. And that leaves us with -6x minus 18z equals 0, and then 6x plus 18z equals 0. So you see again we have that weird situation where both variables disappear, but this time we end up with 0 equals 0. So since we end up with a statement that is true, this is how we know that we have infinite solutions. So a little different than the no solution outcome. So remember, when you have a infinite solution case, we're not done yet. We have to actually find a way to refer to x, y, and z in terms of some other variable, which we'll call t, to create a kind of template that would allow us to find any solution quickly. So for this, we're going to look at either of our two equations with two variables. And then we're going to pick either z or x to set equal to t. So you kind of, if you're strategic here, it makes your job a little bit easier. So here, the easier thing to do would actually be to let z equal t. Okay, and you'll see why in a second. So let's assume that I plug that into maybe equation 4. So if I do that, we have 3x plus 9t equals 0. And now we can solve for x really easily. So we end up with x equals negative 3t. So now we have z in terms of t. Z is just equal to t. We have x in terms of t. And to find y, we're going to substitute both of these into one of our original 3. So I'll substitute them into equation 1. So here we have negative 3t for x minus y plus 5 times t for z equals negative 2. And then here, if we solve, we end up with y equals 2t plus 2. So now we have x, y, and t in terms of t, so we can write our answer, or what our answer will be. So x again is negative 3t, y is 2t plus 2, and z is simply t. So again, the whole purpose of creating this type of answer is, since there's an infinite number of solutions, if you have something like this, you can plug in any number for t and it will give you one of the solutions. So for example, right, if we use t equals 1, then we have the coordinate negative 3, 4, 1. That's one of the solutions to our system, where if we have t equals 0, we have 0, 2, 0, which is another solution to our system. So again, this gives us a way to describe all of the possible answers without, needing to actually list them all out, which would be impossible. So this is how we're going to write our final answer. Okay, here's the last you try. So please pause the video and give it a try on your own, and then we'll check your answer in just a few seconds. Okay. So you can see here, the strategy that I chose to use was to eliminate my x's twice. So I did the negative of equation 2 and equation 3, and negative 3 times equation 1 plus equation 2. So I got these two equations, and then I used elimination there, and I ended up with the expression, or the equation 0 equals 0. So that tells us it's infinite solutions. So again, we need to find a way to describe x, y, and z in terms of t. So looking at these two, one of these two, I chose to set z equal to t. I substituted into equation 5 right here, and that gave me y equals 3t plus 2. And then I substituted these values into equation 1. Here's 3t plus 2, and here's the t, and it left me with x equals negative 2t. So this is our solution. All right, so that is all for today's video. Thank you so much for watching.